Now we have the ionization energy of hydrogen atom. So ionization energy means the energy required to liberate or to free the electron from the atom. It means that the valence electron goes to infinity. That case the atom is ionized. Energy of nth energy level. Now this En equal to minus 13.6 n square z square electron volt. This is not so much. Now the ionization energy energy required is called ionization. Ionization. So this ionization energy equal to 0 minus 13.6 z square upon n square, so much electron volt. So this is equal to plus 13.6 z square upon n square electron volt. This is not so much. For hydrogen atom, this is for hydrogen-like atom. For hydrogen atom, Z equal to 1 and the electron lies in the ground state. N square electron volt. In hydrogen atom, electron lies in ground state. Lies in ground state. So ionization energy of hydrogen atom, this is equal to 13.6 electron volt. So much energy is required to liberate the electron from the atom, from the hydrogen atom. Now if this electron lies in somewhat other energy states, suppose this second energy state, third energy state, fourth energy state, then we are having the different ionization energies. So this energy 13.6 electron volt is called the first ionization energy. It is also called the first ionization energy. Of hydrogen atom. Now, if the electron lies in second, third, etc. energy states, then binding energy is called second, third, etc. Binding energy. So now second binding energy. This is equal to 13.6 upon 4 electron volts. So this is equal to your 3.6 electron volt. Third binding energy. This is equal to 13.6 upon, this is now your 9 electron volt. So this is 1.51 electron volt. So as the electron is found in the excited states, more and more excited states, this binding energy goes on decreasing. So you can see that the first binding energy is the 13.6, second is 3.6 and 3.4. 3.4 and the third is 1.51 electron volt and so on. So it can be calculated by putting the value of n equal to 1, 2, 3, 4, 5, 6 and then you find the first, second, third binding energy of the hydrogen atom. If suppose we have to find the binding energy of the hydrogen-like atom, then you put the value of Z and find that where this last electron lies. So now in the next I will take the ionization energy of the hydrogen-like atoms. So thank you.